Hey everyone, Chris here. So I'm back now, and now that we're finally done the component manager, we can actually get back to the game object class. It's been quite a while since we've been in here because a lot of things just sort of got in the way. But we're just going to jump right into this. So if you remember where we left off on the game object create, where we create a transform and we set up its game object to be this game object. And then now we're going to we're going to actually set the transform for this class. We're going to set the member variable instead of just the local variable. And so what we do for this is we're just going to add the component to the component manager. And I don't think I actually included component manager here. Yes, I did not. So we need to include component manager here. Let's get that down on its own line. Include that in there. Now this will work, or it should work there. Well, let's just type it out. Oh, that's why it's a static. This actually needs to be a get instance, right? It's a singleton. So we want to get the instance, and then we want to add component, and we're going to pass in the local transform here that we created, and then we're going to add the component to this game object. So we have a list of it here. And this will initialize the component. And we'll get to that in a minute. So it's now actually associated with the game object. Now we're going to write the destroy function. So first thing we're going to do here is at the top, we're going to call component manager. We can actually just copy this singleton call here from the previous function. And then we're just going to go through and we're going to remove components with game object, and we're going to pass in this. And that'll clean up all the components associated with this game object. Now I'm just going to go over and grab what I need here, the game object vector iterator here, just so I don't have to type everything out every time. And we're just going to go through and we're going to clean up all its children, because when we remove the game object, we also have to remove all its children. That's not equal to mChildren end. ITR there. Go, and in here we're just going to do this, or not type this, but this, and just call its destroy. So this is a recursive destroy here. And then after that, we're going to make sure we delete the iterator. Make sure we dereference it there. So now we're just going to do the same thing for the components, except this will be much simpler. We don't actually have to call destroy on the components. That's the component manager's job. So here we just go through, and this is mComponents, and we're just going to delete the iterator. Now, just for good measure, we always want to make sure that we clear the vectors as well. You don't want to leave the vectors, because even though we've deleted the objects they're pointing to, those vectors still will see stuff, and you can get memory errors when you try and access stuff. So that's it for the destroy. Now we're going to go through and write the add component. Alright, for the add component function here, we're just going to go through and create that. So basically we're going to make the assumption that, or we're going to, and actually not an assumption, we're going to create a restriction here with this. This will just make things easier in the long run. We may take it out eventually, but for now you won't be able to have multiple components of the same type on the object unless they are a script component. Because script components, you want to be able to have many of those. Or you want the possibility to have many of those. And then we're just going to call the find component by name here. And we're going to pass in the L component name. And this will, once we implement it, it'll actually check to see if there is a component of this name. So we're just going to do this here. We probably don't actually need that else statement. Eventually we'll want to add error handling in here that lets the user know. So we'll leave it in there for now, but right now it's actually going to be empty. So when we add the component here, we just want to set the L component game object to this. We want to add it to the components. Now I'm just looking up here. We don't actually need, well, yeah, we should leave that in there anyways. That's useful. So we're not going to make any changes there. We're just going to push back the M components. We're going to push this back onto M components. And that'll just be L components we push back. Oh, hey, when I don't hit the shift key there. For some reason that's throwing in, oh, it's because it's not a pointer. There we go. And then we're just going to call start on the component. So as we talked about earlier, there's the start function and awake function. Awake is called when it's added to the component manager. Start is called when it's added to the game object. And so that will happen at runtime, basically. That's it for the add component by game object. Now we're going to go in and do find component by name. Now we actually have to go over to component first and write something over there. So we'll be back in a second when we're ready to do that. Alright, and we're back. So we're just going to write a quick helper class for component. I actually keep it with the, oh, it's actually not even class, it's just a struct. And I actually keep it with the component because it is integrally tied with the component, and it doesn't make sense to have two includes for something that every time you include component, you're also going to want to have component comparer. So what this is going to do is this is going to wrap comparing components by name, so that we don't have to write a bunch of code every time to actually do this. This will allow us to use the iterator compare, or well, standard find if actually is what we'll be using, and that returns an iterator, which we can use to find out if the component exists. So we're just gonna write this struct out here. Make sure I can spell things right. And there's actually not going to be a default of this of anything because there's no need for a default. It will never be. This is not a struct that will ever be initialized. We don't need to do that. We can just do mname. Do this in a more modern way of doing coding, I guess, is passing stuff like that. And then we're just going to create an overloaded operator here. And this is going to be for those brackets there. And it's going to take in a component pointer, and we'll just call it L object. And then inside here, we're just going to return if L object mname is equal to mname. No, let's fix that so that actually says L there. And then we're just going to return true if it's equal, false if it's not equal. So this is just a short way of doing an if statement basically here. It just keeps things concise. And that's it for the component comparer there. Put this down the next line. Like I always write them down there. Other than that, so that's it. So now we can go back to game object here and start writing the find component by name. So we're going to use the component vector iterator typedef that we created. Should probably rename these, but I like leaving things as very defined names so you can easily figure out what they are, even if it takes a little bit more typing. And then we're going to use the string find if, and then we're going to pass in components begin. We're going to pass in components end here. And then this is where we're going to use our component comparer. So we're going to pass in our component comparer. And we're going to pass in name. And then we're just going to close that off. And that should be it. There's a spelling mistake there. Oh, no. It's not a comma there. And I think we also... No, we already have algorithm included over in the header for this class, so we don't need to include that. But you will need to include algorithm anytime you use any of these, which are incredibly useful. And they're fairly robust because the standard library is really, really robust. So they're a good thing to use when you don't want to write them yourself. Although later on I actually will be writing one to do a find all, and I basically modeled it on the standard library one, but we'll get into that later. So next we're just going to check to make sure that the iterator that we find is not equal to the end of the array, and if it isn't equal to the end, we're just going to return the iterator. Otherwise, we're going to return null. We want to make sure that we return null because then we can do a null check to find out that it isn't there. Because if we just assume it's always going to be there, that would be very bad coding and would lead to a ton of issues later on down the road. So let's just finish up this game object class here real quickly. This one is we haven't written the game object comparer here either yet, which we're going to use. So we have a component comparer and a game object comparer, and they basically do the same thing except they work on game object and components. So we're just going to head back over to the header here and so nice thing about already having written this for the component comparer, we can just rename this, call it game object comparer, and rename that there, and we now have a game object comparer that does the same thing on name. Oh, and I think there's an error with the component comparer over here. Yeah, that should be name and not name, not name. Right, so there we go. So now that's done. So, oh, I don't want to blow that up there. Let's put that back on the bar. So now in the add child, we're just going to go through and work on that now. So first thing we're going to do is we're going to go over and I like copying and pasting stuff. We're just going to grab the game object vector iterator, and we're just going to do this, and we're going to use the standard find if, and then just pass it instead of component. We're going to use mchildren dot begin, mchildren dot end, sure that's an underscore there, and then we're just going to pass in the game object comparer, and we're going to pass in game object pointing to M name. Close that off there. And we can actually do the same thing above. We can just copy this and just change M components to M children. And we're good to go there. Oh, I forgot we need to also set a return type for here. So we're going to have to change that in the header as well. Looks like I forgot to do that earlier. So, oh, we already have it in the header, just not here. Oh, and that was silly. I actually wrote this in the wrong function. So let's actually fix that. This is actually going to go down here. That's what happens when I'm looking back and forth between two screens trying to follow through code. So now let's actually write add child, which is what we were supposed to be writing. So we're going to go through and we're going to set mParent equal to this. We're going to call create on the game object. And then we're going to push back this game object to the list of game objects. Alright, so now that we've actually written that, there we go. So we just have the one last function to write here. And this is the one where we have to find all children by name. So this one I'm going to have to go back and we'll be right back in a second while I prepare to write that one. Alright. Alright, so the first step here, you're going to want to go over and you want to add a new header item. And we're just going to call this find all. So this is a little bit more advanced code, but I actually just I basically took a look at what they did for the I took a look at the algorithms code that they wrote, and this is just based off of that. So this is going to be a template function, and it's not going to have a class or anything like that. So this is based on the code, although I changed some things, like I use type name where they use class, although I kept all the names similar so that you can see exactly where it came from. So that's why this naming convention is sort of weird and not normally what I use, because I base this entirely off what they did. So in the standard find if, they just return an iterator, where here I'm actually going to return a vector of iterators. Call it find all there, and then we're just going to this first and call this last. Sure, I throw those underscores there. Just correct it so that it looks right, because I'm basically reading off my other code which I've previously written. So before I did the series, I actually wrote all this code once, and now I'm writing it again. So I'm actually writing everything you see here, I'm writing it twice. So it took a while to prep all this stuff, but that's okay. Once we finish this here, we can finish the game object class for now. Alright, so what we're going to do here is we're going to create a for loop. And this is just going to be put together so that we can loop through every item that we want to loop through. And we're just going to go through. So basically what this is doing here is, since first is already, we don't actually need to declare anything, setting anything up, because that was passed in. And then we're checking to make sure that first is not equal to last, and then we're incrementing first. So it's definitely a short form if statement, or a for loop rather. Then we're going to run the I guess it's not really sure what they call it. This a predicate or something. I'm not exactly sure what they refer to it as, but what it is basically it's calling the function and passing in the parameters of a function to compare. And so this is and then it will return true or false. And if it's false, it won't add it. If it's true, we will push back first on here, which will to our vector of iterators. And then at the end here, we're going to return L result. Right, and so that's a nifty little thing here that will allow you to search for all the iterators or something, rather than just a few of them. So I may actually I may change this stuff later, because you can do the iterators, but I may change it to actual objects. I'm not sure yet for that, but right now we're just going to leave it as objects.